Now we are going to discuss about the matrices concept session. What is the definition of a matrix? A rectangular arrangement of numbers. An arrangement of numbers which are arranged in the form of a rectangular array like this. Rectangular array means numbers are arranged in the form of some horizontal lines and in some vertical lines. This arrangement is known as a rectangular arrangement. So numbers are arranged in the form of some horizontal lines which are known as rows. Horizontal lines are known as rows. Vertical lines are known as columns. So, arrangement of numbers, either real numbers or complex numbers, which are arranged in the form of some horizontal lines and in some vertical lines. That horizontal lines are known as rows and vertical lines are known as columns. That arrangement is said to be a matrix. In general, the element present in a matrix is denoted with Aij. The order of the matrix is said to be m by n. If m is number of rows and n is number of columns, then order of the matrix or type of the matrix is written as m by n. This should be read as m by n but not m into n. So what is the meaning of Aij? Aij means the element present in ith row and jth column. The element present in ith row and jth column is denoted with Aij. For example, A12 means this element is present in first row, second column. That is the meaning of that notation. So in general, a matrix of order m by n is denoted with capital A is equal to Aij m by n. Elements are always represented by small letters and matrices are represented by capital letters. Order of the matrix or type of the matrix is m by n means it has m number of rows and n number of columns. So order 5 by 3 means that matrix has 5 rows, 3 columns. So what is the definition of a matrix? An arrangement of numbers, either real or complex, in the form of a rectangular array. Rectangular array means some horizontal lines, in the form of some horizontal lines and in some vertical lines. Those horizontal lines are known as rows and vertical lines are known as columns. If a matrix has m number of rows and n number of columns, then its order or type is said to be m by n. Any element present in the matrix is Aij. Aij means the element present in ith row and jth column. So this is the definition of matrix. Then what are the different types of matrices? First, rectangular matrix means a matrix in which number of rows and number of columns are not equal. For example, if you look at this, it has 2 rows and 3 columns, so its order is said to be 2 by 3. Since number of rows and number of columns are not equal, this matrix is known as rectangular matrix. Next, square matrix means a matrix in which number of rows and number of columns are equal. For example, this is a matrix having 2 rows and 2 columns. So its order is said to be 2 by 2 and it is known as square matrix. Rectangular means number of rows and number of columns are not equal. Square matrix means number of rows and number of columns are equal. Next, what is a row matrix? A matrix which has only one row and any number of columns is known as a row matrix. It should have only one row and number of columns can be any number. Next, column matrix. It is a matrix which has only one column and any number of rows. That is about column matrix. What is principal diagonal of a matrix? Principal diagonal is defined only for a square matrix. The elements which have same row number and column number. For example, if you look at this element, this is the element present in first row, first column. This is present in second row, second column. This is present in third row, third column. So the diagonal which contains the elements having same row number and column number is known as principal diagonal. That is the diagonal which contains the elements having same row number and column number. That is known as principal diagonal. It is defined only for a square matrix. Next, what is a diagonal matrix? Diagonal matrix means except principal diagonal elements, all the other elements will be zeros. This is known as diagonal matrix. Other than principal diagonal elements, every element should become 0. Next, triangular matrix. We have upper triangular and lower triangular. If all the elements below principal diagonal are zeros, this is principal diagonal. If all the elements below the principal diagonal are zeros, it is known as lower triangular matrix. Sorry, upper triangular matrix. Suppose if all the elements above the principal diagonal are 0, it is known as lower triangle, which is given in the above table. So if diagonal elements below, if elements below principal diagonal are zeros, it is upper triangular. If elements above principal diagonal are zeros, it is known as lower triangle. Next, what is a scalar matrix? After knowing what is meant by diagonal matrix means other than principal diagonal, every element should be. If all the elements other than principal diagonal are zeros, it is known as diagonal matrix. Scalar means all the principal diagonal should be same, remaining elements should be zeros. This is known as scalar matrix. All the principal diagonal elements should be same. If all the principal diagonal elements are unity and remaining elements are zeros, it is known as unit matrix or identity matrix denoted with capital letter I. So all these are given in the above table. Next, idempotent matrix. A square matrix in which A square is equal to A is said to be idempotent. A square matrix A is said to be idempotent if A square is equal to A. If A square is equal to I, it is known as involutory matrix. Next, what is a periodic matrix? If A is a matrix, square matrix, such that A power k plus 1 is equal to A, where k is a positive integer, then it is known as periodic matrix and the least value of k is set to the period. So what is the definition of periodic matrix? A square matrix A which satisfies A power k plus 1 is equal to A, where k is a positive integer, is known as periodic matrix and the least value of k is said to be the period of that matrix. Nilpotent already we discussed. Involutory already I told you. If A square is equal to I, it is involutory. And what is nilpotent? If A power n is equal to null matrix, where n is a natural number, if A power n is equal to null matrix, then it is known as nilpotent. And the least value of n is said to be the index of the nilpotent matrix. Least value of n is said to be index of the nilpotent matrix. Next, symmetric and skew symmetric matrices. If A is a square matrix such that A transpose is equal to A, then it is known as symmetric. If A transpose is equal to minus A, then it is known as skew symmetric. If A transpose is asymmetric, if A transpose is minus A, it is skew symmetric matrix. Remember, in case of skew symmetric matrix, all the principal diagonal elements will be zeros, and whatever the numbers you have here, same numbers will be here with opposite signs. Whatever the number you have here, same number with opposite sign. This is an example for skew symmetry. All principal diagonal elements will be zeros, and the numbers here and the numbers here will be same with opposite sign. Similarly, number here and number here will be same with opposite sign. Then what about symmetric? Write any three principal diagonal elements, and whatever the numbers you are writing here, same numbers vertically, and whatever the number you write here, same number here. See, these numbers and these numbers should be same, and this number and this number should be same. Principal diagonal, you can have any numbers. This is how an example for symmetric matrix can be written. So this is about symmetric and skew symmetric matrices. Next, orthogonal matrix. A square matrix A is said to be orthogonal if A into A transpose is equal to a unit matrix. And we know that if AB is equal to BA is equal to I, then B is said to be inverse of A. Similarly, if A into A transpose is I, A transpose is said to be inverse of A. This is about orthogonal. Next, concept of determinants. First, what is meant by minor of an element? Suppose if you consider a matrix like this, A1, B1, C1, A2, B2, C2, A3, B3, C3. If you want to find minor of an element, minor of A1, delete the row in which A1 is present, delete the row and column in which A1 is present. A1 is present in first row, first column, delete those two. And for the remaining part, you have to find determinant. B2, C2, B3, C3. And what is the value of this determinant? B2, C3 minus B3, C2. This determinant value is known as minor of A1. So how to find minor of any element? Delete the row and column in which that element is present and find the determinant of the remaining part. That gives the minor of an element. Minor of an element is generally denoted with Mij. Minor of the element Aij is denoted with Mij. Next, what is cofactor? Cofactor of an element Aij is nothing but minus 1 power I plus j into its minor. We know how to find minor. After finding minor, multiply that minor with minus 1 power I plus j. What is I? Row number of that element. What is j? Column number of that element. So what is cofactor? Minus 1 power I plus j into its minor. Next. What is the definition of determinant of a matrix? This is very important. Determinant of a matrix generally we denote with delta. It is nothing but sum of products of elements and their corresponding cofactors of any row or column. Suppose if you consider first row, what are the elements we have in first row? A1, A2, A3. Multiply those elements with their cofactors. Cofactors are denoted by the capital letters. A1 cofactor is denoted with capital A1 plus A2 cofactor is denoted with capital A2 plus A3 cofactor is denoted with capital A3. So what is the definition of determinant? It is nothing but the sum of what? Products of elements and their corresponding cofactors of any row or any column. So you can take either first row, second row, third row, or first column, second column, third column. Consider the elements in that, multiply those elements by their cofactors and then add. That gives a determinant. So here I considered first row elements and I multiplied with their corresponding cofactors and then I added, then I get determinant of that matrix. Suppose if you take first row elements and if you multiply with cofactors of second row elements, what are cofactors of second row? Second row elements are B1, B2, B3. Cofactors will be capital B1. I am taking elements from first row, but I am multiplying with cofactors of second row. In that case, this is not determinant. This value will be 0. So, observe the difference between these two. If we consider a particular row and if you multiply those elements by their corresponding cofactors and if you add, that gives determinant of the matrix. But if you consider elements from first row and if you multiply with cofactors of second row and if you add, then you get 0. Next, what is adjoint of a matrix? Adjoint of a matrix is nothing but transpose of cofactor matrix. Then what is cofactor matrix? We know what is meant by a cofactor. Cofactor matrix means the matrix obtained by replacing all the elements by their cofactors. Replace all the elements by their cofactors, then you get a matrix known as cofactor matrix. Transpose of that gives adjoint. That is what is meant by adjoint of a matrix. And whatever the properties that are given here based on adjoint, all are very, very important. A into adjoint A is equal to adjoint A into A is equal to det A into I. Det of adjoint A, det A whole power n minus 1. Adjoint of adjoint A, det A whole power n minus 2 into A. Determinant of adjoint A, det A whole power n minus 1 whole square. Adjoint of AB, adjoint B into adjoint. Adjoint of KA, K power n minus 1 into adjoint A, where K is a scalar. Each and every property mentioned here based on adjoint is very, very important. Next, what is a reciprocal matrix or inverse of a matrix? Already I gave. If A and B are two matrices such that AB is equal to BA is equal to Y, then B is said to be inverse of A. And replace that B with this. Therefore, what you get? A into A inverse is equal to A inverse into A is equal to I. That is, any matrix multiplied with its inverse gives unit matrix or identity matrix. And the formula for finding inverse is adjoint A by det A. This is the formula for finding inverse of a matrix or reciprocal of a matrix. And the necessary and sufficient condition for a square matrix to have inverse is det A should not be 0. Why det A should not be 0? This is the formula for inverse, right? If det A is 0, denominator becomes 0, inverse doesn't exist. So for a matrix to have inverse, remember det A should not be 0. Next, system of equations. Here there are two types of system of equations. One is homogeneous. Homogeneous equations means right hand side will be zeros. If right hand side of the three equations are zeros, then those are known as homogeneous system of equations. For homogeneous system of equations, always a solution will be there, which means no solution case doesn't arises. No solution case doesn't arises in case of homogeneous equations. So when homogeneous equations are given and if we are supposed to find whether they have solutions or not, definitely answer will be they have a solution. There are two cases here. That solution may be a unique solution or infinite number of solutions. No solution case doesn't arise for homogeneous equations. Answer can be either unique or infinite number of solutions. What is that unique solution means? X, Y, Z, 0. Because x0, y0, z0 always satisfies these three equations. This is known as unique solution or trivial solution or zero solution. So what is that unique solution? x0, y0, z0 is known as unique solution or trivial solution or zero solution. So remember, homogeneous equations have either unique or infinite number. How to know whether these equations have unique solution or infinite number means by finding delta. Already delta is mentioned here, determinant of a1, b1, c1, a2, b2, a3, b3, c3. If delta is equal to 0, then they have infinite number of solutions. If delta is not equal to 0, then they have unique solution. So this is about a homogeneous system of equations. Remember, homogeneous means right hand side instead of d1, d2, d3, here all d1, d2, d3 will be zeros. So for homogeneous, remember, answer will be either unique or infinite solutions. How to check whether they have unique or infinite? By finding delta. What is delta? Determinant of all the coefficients. If delta is 0, then they have infinite number of solutions. If delta not equal to 0, then they have unique solution. What is that unique solution? x0, y0, z0 is known as unique solution, which is also known as trivial solution or zero solution. So this is about homogeneous equations. Then what are non-homogeneous equations? The above equations given are known as non-homogeneous, where d1, d2, d3 will not be zeros. Then how to check for non-homogeneous? For non-homogeneous, there will be three possible answers. They may have unique solution, they may have infinite number of solutions, or they may not have a solution. So no solution case also arises for non-homogeneous equations. Then how to check whether the given non-homogeneous have unique or infinite or no solution means again by finding delta. Suppose, what is delta? Determinant of a1, b1, c1, a2, b2. If delta is not equal to 0, then they have unique. If delta, delta 1, delta 2, delta 3 all are zeros, then they have infinite number of solutions. Infinite number means everything will be zeros. Next, if delta is 0 and at least one of delta 1, delta 2, delta 3 not equal to 0, then they have no solution. So these are the three possible cases for non-homogeneous system of equations. Delta 0 and at least one should be non-zero. Then it is known as, then they will have no solution. So whatever we discussed, everything is given under the table. Already I told you what is homogeneous equations and what is trivial solution, everything. So the explanation which I already gave is here, given here.